He's welcome to come right up here. All right, number 11, here we are. We're still on worksheet 1. And problem number 11 says, a stone is thrown. So height above the ground is given by this equation, which we used this equation before, so we don't have an issue with it. The last time we used this equation, or at least a lot of the times we used it, that was a 16. And if the problem is in feet, measured in feet per second, or the height is in feet, that number will be a 16, a negative 16. If it's in meters, it's going to be a negative 4.9. That's the gravitational constant, okay? So that's why it's a little different than when we did the 16. Okay, when will the stone reach its highest elevation, and when will the stone hit the ground? Okay, so you've got your equation. Now you're going to answer those two questions. And what are we going to do? When will it reach its highest elevation, and when does it hit the ground? All right, so how do I do this? Come on, I need a volunteer. Yes. And what would I do with it once I plugged it in on my calculator? Find what points?
Or find
the maximum. All right, let's stop right there. She says if I want the highest elevation, that would imply maximum, right? What kind of equation is this? Look at that degree. What kind of equation is that? That's a quadratic. I'm not going to type it in on my calculator. That takes you guys way too long. You want the vertex? You're going to do negative b over 2a. Now, I'll type that in my calculator to see what that equals. I think it might be something not too bad, actually. 14 divided by 9.8 is 10/7. Okay? Now, what does that mean? What does that 10/7 represent? That is when it reaches its highest point. Now, the question says, when will the stone reach its highest elevation? 10/7 seconds. I'm simply finding the vertex, negative b over 2a. When will the stone hit the ground? Now, a suggestion has been made that I plug 10/7 in for t. Now, can I do that? Absolutely. And it will give me this number right here. Is that when the stone hits the ground? No. What is that? That's its maximum height. Isn't that its maximum height? So if I got 30, let's say 40 for that number, that would mean its maximum height is 40. That was not the question. The question wants to know, when is it on the ground?
Plug in 0.
For
T.
For t? If I let t be 0, that's this point right here. Right? That's where I am before I throw the ball, which I already know is 30 feet off the ground. How do I find when it's on the ground, John?
Set it equal to 0.
I set it equal to 0. This is the height. You want the height to be 0. So you're going to solve that equation right there. So t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so this is what I have a calculator for.
4.29.
Oh my gosh. Okay, I made a mistake somewhere.
I got 4.29.
got an answer?
4.29.
Okay,
Rounded to the nearest hundred.
let me try this one more time. Oh, okay. Okay, so I got a negative answer, I'm gonna throw that out. Let me try the other one. And see if I can get. Yeah, 4.29?
Yeah.
That's what I got. Now, I got a negative answer for my first answer, and that's because when I did one of my roots, I got this answer back here, which is okay, that's a 0, but it doesn't make any sense because t would be negative back here. So I threw that one out and took 4.29, oh, no, that's the one I'm gonna keep, threw this one out. 4.29 as my answer.
So why couldn't we graph this with a calculator to find the maximum and 0?
You totally could, except this could show up on the no calculator part of the test. If it's a quadratic, you need to be able to find the vertex without a calculator. Now, I know the numbers in this problem made the arithmetic really messy, but conceptually, you need to be able to find the vertex of a parabola without your calculator. Okay? So, that's why. Find the maximum volume of a box. So, have we done this before? Yes.
Yeah.
So let's set it up. How big is the paper? 10 by 14. So what is your equation? If the paper is 10 by 14, you're cutting the corners out. Remember how we do? It's the same box as always, nothing tricky or different. What's the setup?
X parentheses 10 minus 2x.
10 minus 2x.
And parentheses,
14 minus 2x.
Correct.
Times x?
Yeah.
That's your volume. So when it says find the maximum volume, we want to find the maximum value of this. Now, is that going to be an x squared equation? No. So there's no vertex. We're not doing vertex with that one. We got to put that one in our calculator and find the maximum volume. So I'll let you do that right now real quick. Should be 120.164. See if that's what you come up with. Okay, we getting that? Yep. 121 point something. Or 120 point something, I mean 120. Okay? Anybody match that? They're looking at the right answer on the sheet. Alright, if you're not getting that, you need to come find me and we need to work on it because we're not taking any more class time on that. So we're moving on to the next problem. Here we go. Number 13. This is one of those deals where we're selling something, okay, and then we decide we're going to change the price, and that of course will affect the demand. So in the beginning, I am selling 80,000 magazines for $1.60 each. So would you all agree that this, whatever this is right here, that's how much money I'm bringing in right now? That's my revenue. But now I'm going to change things. What am I going to do to my price? What's happening to my price?
Drop 10,000 customers every 40,000. Every 40
Okay, so what's happening to my price?
Every 40
It's
seconds.
increasing in increments of 40 cents. So my price is going up in increments of 40. what is happening to my, sales then? Going down in increments of 10,000? So what is my new revenue equation? This was my original. This is what I make if I don't change anything. What's my new one? 80,000 minus 10,000 X and $1.60 plus 40 cents X. Your sales are going down by ten thousands, and your price is going up by 40 cents. Now, we want to know the maximum revenue or the maximum income, okay? Could I do this without my calculator? Yes, because if I FOIL this out, what kind of an equation will it be? A quadratic. So I'm going to go ahead and FOIL it out. And I'm using my calculator to help me do the multiplication because I'm too lazy. Okay, so if I did my multiplication right, I got negative 4,000 x squared plus 16,000 x, is that right? And then plus 128,000. Okay, so my vertex will be negative b over 2a. Did you get x equals 2? Now, to what? $2, 2 magazines, to what?
2 changes.
2 changes. So what was the question? What price per copy maximizes income? Okay, so what was my original price? $1.60. I'm going to change it twice. That's what this means. I'm going to change it twice. Each change is worth 40 more cents. So that would be a total of what? $2.40. So that's the price you should charge for your magazine. $1.60 plus 80, 2.40. Find the dimensions of the largest picture that can be framed by a blue and gold ribbon that's 124 centimeters long. So in other words, this is like the fence problem, only you're doing all 4 sides, so all 4 sides are getting ribbon, and we have a total of 124 centimeters of ribbon. So we want to maximize the area. Okay, so what do we need to do? You need an X. So Chandler says one side's X. It makes absolutely no difference. I'm going to call this X. Now, I need an expression for this. 62 minus X? Now, it is 62 minus X. How did he get that? Well, in a rectangle, won't this squiggly be the same as the unsquiggly?
Yeah.
So if the whole shebang is 124, wouldn't the squiggly have to be 62, half of it?
Yeah.
And if that chunk is X, then that would be the leftover 62 minus X. So my area is simply X times 62 minus X, or 62X minus X squared. what kind of an equation is that? Quadratic. I want the maximum, so I want the vertex. So x equals negative b over 2a. So x is 31. Now what did the question say? Find the dimensions. So this side's 31. What's this side? 31. So what are the dimensions of the biggest picture you can frame? 31 by 31. It's a square. Okay. And last one. Cafeteria. All right, so they have given me two equations. Very complicated, got a bunch of decimal points and stuff. Don't get freaked out. One of the equations is the supply equation, and one of them is the demand equation, just like you have in econ. Find the price when supply equals demand. All right, so what are we going to do? We're going to set them equal to each other. So you've got two equations, and you're going to set them equal to each other. You're going to find out where they are equal. So we're going to have 200 minus p, this is awfully small for my old eyes, plus 0.123450 zeros, p to the 4. That's going to equal 1500 minus 0.0004 p cubed. I hope I have the right decimal number of zeros in there. Now, I think we talked about this, but maybe we didn't. You have two ways to solve this. It makes absolutely no difference. It's whichever way you're most comfortable with. Did we talk about that? One option would be to move everything over to one side and get your equation equal to 0. Then when you type it into your calculator and hit graph, you'll get some squiggly line. What will you be looking for? If you have set it equal, moved everything over and set it equal to 0, what would you be looking for? Where it crosses the x-axis, the x-intercepts. So once you got it all graphed in, or once you got it all, graphed on your calculator, you would press second calc and then choose the 0 option, right? Because that's what you would be doing, is finding the zeros. So that's one option. Clearly, in this problem, anything negative would not be considered because P is the price, and nobody's going to charge a negative price, ever, anywhere. Is it possible that you might get more than one answer? Yeah, I mean, I don't know. I've done it, or at least I did it a long time ago. I don't know. The other option you have is to put this in as one equation. So, you know how it says y1? Put that in as y1, and then put this in as y2. And then when you press graph, you're going to get two things. What would you be looking for if you have these two things graphed on your calculator? Where they intersect. So if that's how you want to do the problem, you're going to get it graphed, and then you're going to do the same thing. You're going to go to second calc, but instead of choosing 0, you'll choose the option that says intersect. And it'll have you go through the left bound, right bound thing, just like you do for all of them, and it will find the point of intersection. So, that you're going to practice on your own, but I will tell you that the point of intersection, I didn't write down the point of intersection. I set it equal to 0, and I got one answer, and it was 106.99. So that is the price that would maximize, that's the price that would have supply equal demand. That's my break-even price. My break-even price. That's where supply equals demand. Okay? Now, it says, find the number of sandwiches sold. I shouldn't say break-even. That's my equilibrium price. Isn't that what they call it in econ, your equilibrium price? Now it says find the number of sandwiches sold. What would I do? Because this is the price. This is what I'm charging for each sandwich. How would I figure out how many sandwiches I actually sold? Plug that number into my demand equation. This was my demand equation. This is my p-value. So I'm going to take this number and put it right here. And that's going to tell me how many sandwiches I sold. What if I put that number in this equation? This was my supply equation. What would that tell me? How many sandwiches I made? In this problem, does it make a difference which side I put it in? Nope, because supply equals demand in my problem. Okay, so if you're confused by that, spend a little time getting a graph on your calculator.
Can you say again how you got the 106.99?
I graphed it on my calculator. I set the equation equal to 0, graphed it on my calculator, and found the zeros. You have to play with your window. I mean, obviously, you have to play with your window. Okay. Now, I want you to turn to review number 2. All right, so in your packet, we're going to the sheet that's called review number 2. One through 12 are already on video and already posted. I need to do 13, 14, and 15 right now, so it's good extra practice for you. And in fact, look at number 13. Doesn't that look an awful lot like what we were just talking about? We're on review number 2, and we are looking at problem number 13. So our supply function is this, and our demand function is this. And P is again the price. Find the price where supply equals demand. This is review number 2, problem number 13. Find the price where supply equals demand. So what do? You got an option. Do it however it makes most sense to you. What do you want to do? What I like to do is move it all to one side. Well, they're equal to each other. Supply equals demand. I like to move it all to one side and set it equal to 0. And the reason that I like to do that is because when I set up my calculator window, I'm looking for where it crosses the x-axis, right? So I can make my y's pretty small. I'm not worried about my y's. I don't need to worry about y's. I don't care how high it goes. I'm looking for where it crosses the x-axis. Now, I do have to worry about my p's, or my x's, but I know I'm going to start at 0 over here, because it's got to be bigger than 0. And then I don't know, I'll just make something up out here. Maybe I'll go with 50. And all I want to see is where it crosses the x-axis. If I don't see it at 50, I'll make it bigger, right? Till I see where it crosses the x-axis. And that point right there is going to be the answer to the question. That's how I like to do it. If you would rather graph these together and look where they cross, that's fine too. The problem with doing it that way is you do have to be worried about your y's. So you're going to have to adjust your y's too to see where they cross. Make sure your graph's high enough. Here I don't have to worry about it. So whatever that is, that's the answer to the question, because P is the price, and so that would be the answer. All right, Mrs. Ford has 60 pounds of scrap paper, available for quizzes that I'm gonna sell to Mr. Knoll. Each day we weigh, we accumulate 10 more pounds. The present price is $2, but each day results in a 25% decrease. How many days should she wait to earn the maximum income? What's my income right now?
Come in.
Right now, what's my income? $2 times how many pounds? 60. There's my income right now. But that's going to change, right? How does it change? What happens to my inventory? What happens to the 60? Goes up in increments of 10. So 60 plus 10x, does that seem okay with everybody? What happens to my price? Goes down in increments of 25. Make sure you're using 0.25. So 2 minus 0.25. And that's my income right there. That's how much money I'm going to make. So multiplying it out. I have 2.5, negative 2.5x squared plus 5x plus 20. 120. I just FOIL. How do I find my maximum? X equals negative b over 2a. 1. Is that $1, 1 day, 1 ton of paper? What is that? 1 day of waiting, 1 increment, 1 day of waiting. So the question is, how many days should I wait? The answer is 1. 1 day. What if it had said, how many pounds will I sell? Then it would be 60 plus 10. All right, Taylor lives in the house below. She wants to enclose 2 sides of the yard so that the total area of the house and fenced-in yard is this. Find X, the distance between the house and the fence. Okay. So this is another rectangle problem, but this one's a little bit different because we're making the fence a little bit different than we normally do. There's the house, and this is what I'm fencing. And the total area is 10384. Okay, how do I find the total area? Chandler?
How do you find the total area?
Yeah. How do I find the area, period, for a rectangle?
Well, you do length times width.
I do length times width. So this would be my length and this would be my width. Everybody okay with that? Now, I know in the beginning that this is 30 and this is 60, right? That's given in the problem. That's the size of the house. I also know that I'm adding X feet. I guess it's feet. Yeah. So what would be the length of the whole thing? 60 plus X? And what would be the width of the whole thing? 30 plus X? And I know that if I multiply those together, I get 10384. So I can FOIL. And get it set equal to 0. So that'll be x squared plus 90x minus what? Anybody do that?
Negative 8,584.
584, is that what you said? 8584? Now, does this say anything about maximum? No, we're not finding the vertex, we're just simply solving that equation. So what kind of equation is it? Quadratic. I'm sure it factors, but man, I'm not going to take, I don't know. So instead of that, I'm probably just going to use my quadratic formula. I'm going to get two answers. One of them is going to be negative, so I'll throw it out. And whatever the positive answer is when I do my quadratic formula or factor, whatever flips your switch, that will be the x. Was that the question? Find x. That would be it. Okay? All right, so do I see you tomorrow? Did we say we did? No. Yes, we do tomorrow. Okay, so tomorrow we will wrap up our review.